Howdy students, this is chapter 6 worksheet. Let's get started. Which atom would you predict to have the lower second ionization energy? Our two choices are potassium and calcium. Well, potassium is in group 1, calcium is in group 2. Potassium's going to lose one electron fairly easily. Calcium can lose one electron easily and also a second one. So the one that would have the lower ionization energy for the second time would be calcium. List 3 common ions that are isoelectronic with krypton. Krypton is element number 36, so I look to the left and to the right to see which elements could possibly fit that bill. Well, to the left and to the right, to the left I have bromine, which would become bromide, -1. Selenium would become selenide, 2-, and possibly arsenic, which would be arsenide, 3-. Now, you could also have, on the other side, we could have rubidium, which would turn into rubidium ion, strontium, which would turn into strontium ion, and possibly indium, which would be indium ion, 3+. Question 3. If the first ionization energy of an element is 200 Kelvin, and then it jumps all the way to 1,000 and then to 1,100, well, the biggest jump happens from 1 to 2, which means this is a group 1 atom. So A is going to form a plus charge, and that's it. That's the most stable ion. Life on Earth is carbon-based. If life on another planet were based on another element, which would be the most likely choice? Well, elements are similar within groups or families. So if I look directly below carbon, I'll find silicon. That would probably be the best choice. You could have also mentioned germanium, tin, lead, flerovium, but the best choice is silicon. The modern periodic table was arranged by, that was Henry Moseley, increasing atomic number, and Mendeleev's table was based on increasing atomic mass. We're going to rank these from smallest radius to largest radius. What you need to know is that anions have larger radii than cations of the same element. If you're comparing different elements, different story. Let's go ahead and answer the question. Smallest would be the H plus cation. H is neutral. When it gains an electron, it becomes a little bit bigger. Which element has the highest second ionization energy? Well, if it's got a low first ionization energy, then that would be a group 1. And the only group 1 that I see is lithium. All of the other elements have the potential to lose more than 1. So their second ionization energy may not be that high. Which property decreases crossing the periodic table from left to right? Well, that's kind of confusing. If it's decreasing from left to right, that means it's increasing from right to left. And it increases from top to bottom. So we're looking for something that increases when you go to the left and down. And we know that radii is typically the trend for that as well. So radius. Number 9, which element has the greatest electronegativity? Well, let's see. I'm going to go ahead and circle them on here. We've got arsenic, As, germanium, phosphorus, and antimony or antimony. And if I'm knowing the trend of electronegativity, it's to the right and to the top, with the exception, I might add, of group 8A, the noble gases. Those are not in there. None of those are a part of that group, so I'm going to go ahead and choose phosphorus. Number 10, when the species F-, Na+, Ne are arranged in order of increasing energy, for the removal of an electron, what is the correct order? When I have questions like these, here's what I do. I write out the species F-, Na+, Ne. And what I also like to do is I need to relate it to atomic structure. So let's look at the number of protons. Fluorine, to be fluorine, has 9 protons. Sodium always has 11 protons, and neon always has 10 protons. But I also need to look at the electrons. Fluorine has already gained an electron, so that is going to be 10 electrons. Sodium has already lost an electron. It has 10 electrons. Neon is neutral. To cancel out the protons, it will need to have 10 electrons. So We call this isoelectronic, meaning they're different ions, different elements, but they have the same electron configurations. So in order to figure out which one has the most or the least ionization, energy for the ionization energy, then the correct order would be smallest to biggest. We would need the one that has the lowest nuclear charge or the smallest amount of protons. So let's change colors here. Fluorine would be would have the smallest amount of energy. Let's see if I can get my pen to work here. Smallest energy, let's clarify, because it would have the largest radius. And sodium would have the largest nucleus, so it would have the biggest energy required to remove another electron. Right, so increasing would be small to big. I'm going to choose something that has fluorine the smallest, so I'm going to get rid of choice C and D. And neon would be smack dab in the middle, so choice B is my best choice. Next question's very similar. We're going to do the same thing, so let me change my pen color. We've got argon chloride, that's what we call it, chloride, we'll learn that, and potassium ion, K+. Let's look at the atomic structure. Argon has 18 protons, chlorine 17 protons, and potassium 19 protons. Let's look at the electrons. Argon is neutral, 18 electrons. Chloride has gained an electron. Oh man, and potassium is lost. These are also isoelectronic. So let's see, increasing size, that means small to big. So we're looking for the one that pulls the electrons closest to its nucleus. Well, that would be the one with the largest proton amount. And so the smallest that we have would be potassium. Now, this is size, not energy. You got to be careful. Chloride would be the biggest size, not energy. Don't mix up the trends. So small to big, potassium, I'm going to get rid of choice A and D because it doesn't start with potassium. Argon smack dab in the middle. We're going to go with choice C. And we'll go ahead and do question 12 here. In the vapor state, well, that seems confusing. We haven't talked about that briefly. That's just the definition of how we get ionization energies. We vaporize atoms, and once they're in the gas phase, then we look at how much energy it takes to remove electrons. So let's assume all of these are in the gas phase. Well, if I look, I'm going to go ahead and circle them on the periodic table. Sodium, potassium, magnesium, calcium. We're comparing groups and periods. The trend for ionization energy is increasing up and to the right. So magnesium would be in the smallest energy level, 2s, and it would have the most protons pulling in on those electrons. So magnesium, definitely the strongest choice there. We always like to throw some AP exam questions in our advanced chemistry classes to prepare students for if and when they take AP chemistry. So here are a couple of questions you might see in the future. Number 1, use the principles of atomic structure to explain each of the following. In each part, you must include references to both substances. Okay, part A, the atomic radius of Li is larger than that of Be. So let's take a gander. So what I know is that I have to use atomic structure, which means talking about protons, neutrons, or electrons, possibly nucleus. Okay. Commonly, I tell my students to use CER, claim, evidence, and reasoning. What is their claim? Well, the claim is that the atomic radius, the size of lithium, is larger than that of beryllium. So let's go into that. Let's address lithium first. Lithium is in 2s energy level with 3 protons and 3 electrons. Okay, let's go ahead and mention beryllium. Beryllium has 4 protons and 4 electrons, also in 2s energy level. So here's my reasoning. Because beryllium has more protons in the same energy level as lithium, there are higher, I'm going to put Zeph, which we call Coulombic attractions between protons and neutrons, thus decreasing the radius of beryllium atoms. Okay, let's go ahead and move on to the second question. I may need to take my answer down to the bottom portion. B, the second ionization energy of K is greater than the second ionization energy of calcium. Well, I tell my students, you can use orbital diagrams to actually demonstrate or show your explanation. So let's go ahead and do that. Potassium, if I look at potassium, it has, excuse me, we are in the 4s orbital. Now calcium, also in the 4s. If I'm looking at the electrons present, potassium has 1, calcium has 2. Okay, so as far as ionization energy goes, remember, the one before this, if we were to lose electrons, it would go to 3p. And this is where the 3p orbital is currently. The second ionization energy of K is greater than the second ionization energy of calcium. If I were to remove an electron from potassium, K, then if I try to remove a second one, that's why the energy is so much greater. But calcium has the ability to lose 2 electrons in its valence shell and still be okay. So let's phrase that out. I'm going to explain it down at the bottom here. And I'm using atomic structure. Potassium only contains 1 valence electron in the 4s energy level. Let's address calcium. Calcium only contains 2 valence electrons in the 4s energy level. Okay? Potassium will achieve noble gas configuration after the first ionization energy. Or excuse me, let's change that. After the first ionization. Thus, making the second ionization relatively high. And then I'll mention calcium. Calcium can lose 2 electrons without seeing a spike in ionization energy. Okay, there you go. These are the electron affinities for 5 elements. And what I'm going to go ahead and do is sketch out a graph of electron affinity and atomic number so that we can see what's going on. So let's do 13, 14, 15, 16, 17. Let's rough sketch these guys. We've got 12, so aluminum's going to be way down here. And then we got 32, and then it drops, which we're going to have to explain, and then 16 goes up, and then chlorine way up there. Okay, let's define the term electron affinity. EA, electron affinity, is the likeness of an element for an electron. The higher the electron affinity, the higher the energy associated. And to go ahead and explain the general trend, the closer atoms get to noble gas configurations, the higher the EA. So let's talk about this this issue here that we're having between silicon and phosphorus. We are in the 3p energy level, and so if I'm looking at atomic number, this one is going to be aluminum, Al, I'll tag that. Next one would be silicon. Third one, phosphorus. And then if we go on, we can continue. I'll go ahead and change to blue. Sulfur, chlorine. And then if we kept going, we would get to argon. So let's account for the discontinuity. When we get to phosphorus, okay, phosphorus has all subshells occupied with one electron. So it is relatively stable and isn't looking for another electron. Whereas sulfur is 2 away from noble gas, chlorine only 1 away. That's why there's a spike in chlorine. Question 3 says, suppose that a stable element with atomic number 119, symbol Q, has been discovered. Write the ground state electron configuration for Q, showing only the valence shell electrons. Well, Q would be starting a brand new row of the periodic table, and I'm going to go ahead and use the noble gas configuration for oganesson, which is element 118, and 7p, and this would be 8s1. Would Q be a metal or a nonmetal? Explain in terms of electron configuration. Q would be considered a metal because it is found in the first electron shell of the s block, so it would be a group 1a element. On the basis of periodic trends, would Q have the largest atomic radius in its group, or would it have the smallest? Explain in terms of electronic structure. Well, absolutely, it would have the largest radius in group 1a, and that's because the 8th energy level would have electrons furthest, or I should say farther away, than 7th, 6th, 5th, etc.